Thanks for attending. Are we good? Okay. So, welcome all. Let's talk a bit about Project M36. My name is Diogo Biazus. I know it's written with a D, but that's a weird Brazilian pronunciation. So you can actually say Diogo, all in one word, Diogo. And I work at Nulogy. It's a company that works with a co-packing system, so we work a lot of supply chain stuff. And as a lot of Haskellers out there, in my free time, I code in Haskell, right? Anyway, so I was always very interested in relational databases. I have worked with PostgreSQL for a long time, and I always had this issue with object-oriented programming. Sure that my computer won't sleep. Oh my God, I don't have caffeine here. Okay, sorry, just a sec. We can edit this out in the video later. How do I do this? Is this thing? Energy savings? Okay, never. Okay. Nice. Sorry about that. Anyway, so I was always perplexed at how hard it is sometimes to combine our object-oriented I always, oh, whoa. What was back?
The battery, as you're correct. This thing is back. This thing
Right.
is powered by the plug, but this thing's powered by the battery.
Right.
So thank you very much. Peace out.
Cool.
See you back.
Give it up for the purveyor of our batteries. Nice. Okay, now we can truly begin. So we are going to talk about this project, and one of the ideas here is heavily based on the paper that I was referring to called Out of the Tar Pit. First bullet point, read it. It's a very, very nice paper. It's reasonably easy to read, and it's not like super recent. It's, I think, a decade old maybe. So it's interesting to see how some ideas from the paper actually permeate the last decade in software development, right? And I feel that two main ideas behind the paper is first that power corrupts, right? And this we can see on all programming languages. We always have this argument sometimes when I'm talking to people that are, for instance, people that are not into static typing, right? And they say, oh, but I can do these assertions in runtime, or I can use like some sort of static analyzer, right? Even if it was that simple, and we know it's not, the matter of fact is if you give programmers a gun for them to shoot themselves in their foot, they will, right? Yeah. So when you give restrictions, and I saw a tweet a couple of days ago that I found quite amusing. Someone said, oh, if you consider that the restrictions that you put in a development system are like axioms, right? If you give people more axioms, it's easier to derive more theorems, right? Anyway, I won't go super deep into that metaphor. There are people here much more qualified than I am on mathematics. So, but I thought it was interesting. And indeed, giving restrictions in programming environments actually gives us a lot of power to reason about systems. And static typing, for instance, does so with like reasoning statically about our data structures, right? And I think that in a way, laying out data structure as relations also gives you like a lot of interesting properties. And the restriction of if you're only able to use relations, and if you're not able, for instance, to use null, this actually gives you a lot of nice properties. Also interesting that there is somewhere a talk in a QCon or something that the billion-dollar mistake about the null pointer, right? So that's another interesting tidbit. So anyway, so power corrupts, state is a drag, right? Basically, it's saying that essential state and essential logic should be clearly separated from accidental state and of the join, right? Anyway, so we can also use restriction. Oh, we have our audio back. Nice. So we can also use restriction. So I could say that this join here, I'm going to filter using where clause, right? And I'm going to say where name equals Steve, right? So pretty much the same thing that we would have on a SQL restriction. And I can do projection. If you check the project website, they have like in the tutorial, right? Union, the extend like several other groups. It actually accepts nested relations, which is also quite different. I haven't played around with nested relations, so let's not go there right now. But anyway, so this is the tutorial D. Quick tour, right? And of course, there are some other very interesting properties here that are not directly related to the relational algebra, right? But are related to the way that this engine deals with transactions, right? I'll show what I'm talking about. So show relvars. So here I have those variables that I define, the y and x, right? And you notice that here we have master, right? So we actually have a command here for branching. So we have the traditional commit and hold back, right? But we also have a show graph that shows the graph of transactions. And I can actually branch transactions, right? And merge them. So this is also, so let's do the show graph here. So right now we have only like the master branch. Let me just check here how we, so I think it's jump head. So let's try jump head test. Okay, does not exist. Anyway, sorry about that. But here we have the transaction graph operators, right? And here we can actually branch. Oh, so it's actually branch, right? So branch test, right? Okay. Maybe it's not that easy, right? Anyway, live presentations. By the way, if I execute just the tutorial D client, this starts with the in-memory database. So this can be a bit easier for us to play around. So branch test, and then now I can jump head to master, and we can jump head to test, right? And then we can commit and move this transaction graph, and at some point we can merge them if we will. So it's the transaction model here is very similar to what you have in like a Git repository.
What are the conditions on merge look like? So what constitutes conflict or just a state replacement?
Yeah, I'm not sure. I don't know. I think they might have imposed like a serializable condition, but I'm not sure if that is true.
I just wonder if there's certain superset, subset of graph or relation content or any of that.
Yeah.
I'll have to read the tutorial.
Yeah. Well, sorry. guys, as I told you, like I'm still also new to this. So anyway, so this is, for me, this is already interesting in itself, right? So the ability to use the sum types, right? So we get rid of nulls, we get much more precise modeling of our data. And of course, you can use this as like first-class citizens. So these sum types can be used in like where or join conditions. So this is all already very interesting. But another thing that I would like to show is how this plays out in the Haskell side, right? So easy to persist from Haskell. It provides you with two type classes, atomable and tuplable type classes. And if you have instances of those type classes, the names are horrible. But anyway, if you have instances of those type classes, you can actually generate the persistency logic from your types, right? The query language is accessible, so if there is, as a part of the project, a library which is the M36 client, and this client implements a query language that exposes all its data types. So basically, when you write a relational expression in Haskell code, so I prepared this example here. So, yeah. So this is a small piece of code that uses the client, right? So we can see here, for instance, the commit, right? This is a command that I'm issuing to the database. So if we are here in tutorial D, and I just create a relational. Okay, we don't have the new type, so I'll just re-execute our data type, right? And then I have this relation here, right? I can issue a commit, right? And these moves, we have here a show, it's a show graph, right? Okay. So here is our transaction graph, and we are on our test branch, right? And then I have an identifier for the transaction. And as I commit, I move the head of this graph, right? Let's do another example here. I'll just create another relation, commit, and then. Oh, I think it's not here. Oh, it's here, test, yeah. So we create all these transactions that have different identifiers, right? And this can be done. You have an analogous in the Haskell client, which is this commit. And this is just, it's just a constructor for the data type that will be consumed by the client. Right? So it makes it very simple to build these expressions in Haskell. Like, for instance, this other expression that we see here, relation variable, this is basically when I fetch a relational variable, right? If I do like a show expression here, show expression x, right? The equivalent in the Haskell code would be relation variable, right? And then, of course, I can compose this with conditions, so I can add wheres. I don't think I have an example here, but of course, you can compose in this data type here, and this is a relational express base, right? So you can build these relational expressions with like several of these with these functions, And then you execute using this function, execute relational expression, right? And this sends to the engine and retrieves the results. Now, we were talking about how to serialize, and I mentioned that one, for me, of the interesting points is how easy it is to serialize. And what I've done here is I define these properties, and I use type user. So here I define my type user, right? And I derive generic from my type. So this is a device that allows GHC to derive several different type classes based on a generic representation of our type. So when I say here instance tuplable user, it will use these capabilities offered by generic and will create the tuplable instance for my type. Once I do this, user becomes automatically serializable, right? And here is how I actually create an expression that will define this in my database context. So I basically, it's a bit awkward here. I mean, it's not the most beautiful code, but it works quite seamlessly, right? So these two defined expression will take something that is tuplable, will take a name for our relational variable, and then it returns something that can be executed in the context of the database, right? The same thing is done here for new data types. So account state, so one very common use case is I have like a user that was deactivated at a certain point in time, right? And of course, sometimes when we are using SQL, we will define that this inactive date can be nullable. And the users that have this column marked as null, they are active users, right? But here we don't have nulls, right? Which is good because we don't need to overload the meaning of null, and we can be very explicit. So I can say that the account state can be active, or maybe the person, the user just doesn't have a password, right? So let's say I created the user automatically, and I don't have the user never logged on, right? Or I can also, or I could say it's inactive, and then I want to add to this inactive field the date, right? When was this inactivated?
How does that end up being represented inside the relation?
Good question.
Could you repeat the question because the mic is...
Okay. So how this is represented inside a relation, correct? So we will see that this is actually not represented as, this is a first-class value, right? So it's not represented as a sub-relation or composite type. So here is one example that I've done entirely in tutorial D. And you see that the hair type here would be the equivalent of that account state. We could even just use the same idea here. I could just port this over there, and we could say that we have like an account state, right? And then I could say here that this relation, I'll just create a relation with one tuple here. And let's say that this person here has no password. So this is user. So this is account is no password. right? So we see that the no passer here is represented as like a native type, right? It's not enclosed into quotes, so we know that this is not like some sort of text. And now we can filter, right? So we could say we could have another user here. So let's just we can even do like this. Let's build this on the fly. So show expression. We can even reuse that user and just do a union, right? And in this case, we have an account that is active, right? So here I'm using that user variable, and I'm executing a union with another relation that I defined there, but has a different account state.
Do the tuples that you put into a relation have to have exactly the same?
Yeah. So if we don't do this, the union will fail, right? So if I remove the account here, we have an attributes name mismatch.
Can you have a relation that contains multiple identical copies of a row?
No. This is a very, very good question. And this is something that fills the hearts of mathematicians, and I was going to say database. Yeah, but it's wonderful, right? Because it actually well, I don't need to go into detail, but it basically gives us a very, very nice set of properties.
So if we said show expert user union user.
Yeah, let's do that. No, I don't believe it will.
Just give us.
Yeah. Union user, right? So just gives. Exactly. So this is very neat. And of course, we can compose this with other operators. So I could say here where, oh, sorry. Yeah, this is the one. Where account equals active. Oops. All habits die hard, right? So, oops, oh, here, why? I think it's maybe the way we are associating. Yeah, so it was just the associativity there, right? But if I use the correct precedence, I will get the union, and then I filter using the where. And you see that I can filter using active is my constant, right? And of course, if anyone is used to like PostgreSQL, you think, this is trivial because we already have enums, right? But we must not forget, this is not an enum, this is a sum type, right? Which is a whole different, it's a whole different game, right?
This might be too complicated, but if you had an entry in there that had inactive cents in a number of days or something, or a day,
Yeah.
could you in the where clause pull out that day and
That is very interesting. Yeah, I haven't tried that. Yeah.
Similar, having done some mathematical relations, do you have range and domain restriction on these relations?
Sorry?
Do you have range and domain restriction on the relations? So it's like sort of like a one-sided joint. Assuming you're talking about a binary relation.
Yeah, yeah.
Where if you take your user's relation there, it's like your where account is active, but you're restricting it only to the contents of another relation. So it's where account in rather than where
Oh, I see. Yeah, I'm also not sure.
sort of like a superset or subset operation,
Yeah. I mean, they support nested relations, right?
which is similar.
So we might, maybe, yeah. And they might have an operator for that. And you can also, you can probably build something with the true and false relations, like an exists. I'm not sure. I haven't tried that, right? Um,
If you do the show graph again,
the show
graph.
show graph.
Can we read the column with ID text and an entry for that as a subrelation that has one column and one value within it?
That's how I do it.
Uh,
The header of that call, yep, there it is, parent relation.
yeah, there you go.
Do you know why they do it that way,
Merges.
rather than just putting in the ID
Mm.
of that column?
I guess merges. If you've got multiple parents, it'll merge.
Yeah, there you go, probably.
I'm guessing,
But it's a good guess.
they have some sort of merge operation.
There is the merge operation, and I know it's not trivial, but I haven't played around with it yet.
I'm willing to bet they do multi-parent merges, not just two-parent merges. Give them the structure, or at least give them the rules to generate the multi-parent merge if they get that far.
I think I haven't. Oh, I have persisted. So the user is in our test branch. So I mean, just to have some fun, right? Let's jump ahead to master and show the relational variables. So there it is. Our master is still empty, right? And I mean, it's just like interesting because it's something that sometimes I really miss in a database like PostgreSQL, where you are inside a transaction, but you want just to take a peek. How is the universe of people that are not within my transactional context, right? And having this functionality here is just, for me, it's like mind-blowing, right? Oh, I can actually, let's see what these other users are, how they are perceiving the data.
Can we merge from the test branch into the master branch?
Well, let's try. This is totally live code, so yeah, I don't know where the merge. Yeah. So let's see. I have here the. Oh, it's this one. Merge. Jump to transaction, jump to head. Yeah. Note that some transactions, specifically merge transactions, can have multiple parents. So there you go. So we definitely have this possibility. A left join. Sorry, I'm. No, I just don't know how I do this here. Yeah, the problem, I don't know how the null would play out in that. Because the outer join in SQL requires the concept of a null, right? I don't think so. Yeah.
You could probably do it if you did a relational merge on default value, then deploy that merge.
Yeah. Yeah, you can actually just add the missing information. You just define those attributes in the other relation that you're trying to join, and then you do an inner join, and that stuff you do in a way that will never match. So.
Or if the results are
Yeah.
You still have to define the default explicitly somewhere.
Yeah.
You can't just define, you wouldn't be able to just define it as an A, B, and have to take it out. You'd actually have to somehow, depending how strict the mathematical notion relations is going, you have to do something.
Yeah. And another thing that is interesting here is that every relation, of course, oops, let's just go back. Now I really like this stuff. oops. Oh, I think I haven't committed. So, wow, that was such a rookie mistake. Show relvars. Yeah, I haven't committed. So I committed the X and Y to the test branch, but I haven't committed user, right?
So when you jumped, you lost all?
Exactly.
Jump is an implicit abort history.
It's, yeah, it's, anyway. It sort of made sense in my head. When I saw this, I thought, oh yeah, of course, we jumped without committing. It's an implicit rollback. So anyway, what is interesting here is, so I'll just get, we can also redefine user. It's right here in the history, right? I liked our user relation. So, and the data is also not committed. So the data, now let's commit this, right? So at least our data type we don't need to redefine. And of course, we also don't need to establish the variables, right? You can work, that is interesting as well, how easy it is to just define a relational expression, right? And I must say, like after a couple of minutes using this, I was already like enjoying myself, like it was already flowing with in a very natural way. So. Yeah. So we have here our expression user now, right? And what is interesting is that I can do projection, of course, right? So I can say user project over an empty set of columns. Now, this is where the part of the not having the duplicate rows comes into play, right? Because doesn't matter what relation we are talking here. You see, if I project user, I have only one row. Now, if I get our user union, so let's go back to our user union. User union has two rows, correct? Now, let's project the result of this union. And I have one row, right? Because, of course, if we are saying that we don't have duplicate rows with the same values, then every time you project over an empty set of columns, you will have exactly one row. Now, you might have noticed this exactly same value when I started talking, which is the true relation, right? And that's when I mentioned that this is basically how you would do like an exists, right? You can say, is this equal to true? And it is, right?
False
And
you said false and you projected that?
you mean here, compare?
False.
What happens if you do projection of false with an empty set?
Oh, just a sec. So, show expression false, empty set. Yeah.
And that's essentially the only thing that will ever be false when you project over an empty set.
Empty, exactly. Empty relations will be false. Any empty relation. So that's the beauty of it. Like any empty relation, when you project over an empty set of columns, gives you false. And any relation with more than one row will give you true.
Boolean logic as defined over most relational calculuses take the empty relation as false.
Yeah.
And then any non-empty relation.
I'm so glad that we have someone here that.
Even if it has only an empty row in it.
That's not an empty relation.
So if you projected true over the empty set,
Sorry, if I project true,
Yeah, it has one member.
it has one member. It's empty. It has no value, right? But it has one row, and you cannot like get rid of that row, right?
You see, that is not an empty relation. That's just a relation with no columns.
it's just a relation that's empty.
Yeah,
Empty relation.
yeah.
The empty set
Yeah, that. Anyway, so that is pretty much. Oh, and I also wanted to mention support for asynchronous notifications. For me, this is like a big deal. We can even trigger some notifications here. They have also a tutorial specific for notifications. So let's just, I just want to show here how this would work in the tutorial D. I won't show in the Haskell code, but of course, this is also available in a Haskell and in a WebSockets interface, by the way. So everything that I'm doing in tutorial D, by the way, you can do via WebSockets, like using JavaScript. And that is also really cool, right? Anyway, so I'm just going to create, let's create another relational variable here. So person, right? Show exp person, right? And then I want to say notify, and I will create a notification. The tutorial here gives gives a restriction on the relation that we are observing to notify, right? We don't need that restriction. That is just to show that if I want to create, let's say, a notification for when Steve changes, right? I will say observe the value of this relation here, person where name Steve, right?
Your type of notify, so to speak, is a name, a thing you're returning, and the condition on which you're returning.
Exactly, and everything is a relation. So this is another cool thing, because Postgres, again, the comparison with PostgreSQL. By the way, the author of the project also uses PostgreSQL as an example all the time. So that fills me with confidence, because it's like, okay, this person actually knows like a decent relational database system. But anyway, in PostgreSQL, we also have asynchronous notifications that is like an amazing feature to have in a database system. And I've seen some people argue that this might be like conflating some responsibilities that shouldn't be in the database. In PostgreSQL, originally this feature was developed to trigger certain data copies, certain, like, oh, when certain events happen, I just want an external software to make a backup, for instance. So the initial use case for in PostgreSQL was very, very limited, was very much like more of like a bureaucratic use case, right? Administrative use case. Now this takes this idea to a whole different level, because here notifications are a first-class citizen, right? Which means that when I create a notification, I give two parameters. These two parameters are relations. So I say observe this relation, person where name Steve, and when you trigger the notification, bring me the second relation, right? So let's just define this notification, right? I will commit, and then we will update.
What does show rel errors?
Sorry?
What does show rel errors?
Oh, I forget that Control-C here. Anyway, let's just redo that stuff. Yeah, so yeah, doesn't show up as a rel var. We haven't committed, so I'll just commit. Yeah, doesn't make a difference. But the notification trigger requires the commit, right? So if I do the update, nothing will happen. My notification is not triggered. But as soon as I commit, I have a notification, right? And here we can see that it knows that Steve change is the name of the notification, right? And this is what the notification sends us, right? So it's that relation. We could define something completely different and actually much simpler, right? I could say that I just want to notify with the person relation whenever person changes. So we could say, instead of Steve change, we can say person change, right? So let's commit, let's update. Yeah, that update won't really, no, yeah. So what is interesting here is I get a whole relation as output of my notification. Yeah, that's true. I think my update is not here. So it might be sending me.
Looks like it shows you the old state.
Yeah, I think that's what it's doing. Because the change is definitely there. So the notification actually sent me the old state. This might be a bug. I'm not sure.
Well, I can almost see what you might want of that.
Because it's easy to get the new state after you get that notification because the new state's already
Yeah.
committed.
Yeah, yeah.
What you really want is a relation with the old and the new.
In relation to each other.
Yeah.
Yeah, yeah.
If you get a sequence of these in a hurry, you might not be able to get the.
Exactly.
But you can always walk back.
Well, in this one you can.
To be honest, this was a surprise for me. I really thought it was the new state. I haven't checked this before the talk, but
Postgres is notified when you use it.
so in PostgreSQL, the notification doesn't support relations, right? So notification is just a textual payload. Yeah. Of course, you can encode there like some sort of JSON or something, but then you have to put inside a trigger, right? And then, of course, in the triggers, you have all that flexibility. You can put before, after, and. But anyway, what is interesting about this is that I can receive things that are being updated. As we've seen here, getting the new state might be a bit trickier. But again, this might be a bug. And this is part of the infrastructure that is mentioned on that paper out of the tar pit, right? Because you need not a way, the paper draws a clear distinction between pushing data to your database and having data pulled out of the database as it changes, right? And it's funny because he calls in the paper this style of programming FRP, functional relational programming. And there's even a footnote, do not confuse with functional reactive programming, which has several similarities, right? But yeah, this is the sort of thing that it would be very, very useful in this situation where I have like observers, right, that just like take the data and present, and I have feeders that are actually changing the state on the database. So indeed interesting. That was what I had to, we can go back to the Haskell code. So create feeders using relational expressions. So if we connect the dots, right, what we can do with this stuff. So as I was saying, like you can actually create feeders. You can create these very simple functions that just transform your input, right? And create relational expressions from this input. And this can be done not only in Haskell, as we've seen with that very simple serialization technique, but can also be done in Tutorial D. And using the WebSocket server, you can basically create the Tutorial D expression using a JSON data structure, right? Feeders will convert the input into this essential state. So the idea here is I basically take the input from the external world and I format in a way where this creates my essential state. And then I can create observers using the asynchronous notification system, and these observers will generate my output, right? And they will keep my output in sync with my state. And just to close, just before we close, I just wanted to show that here, unfortunately, I couldn't I couldn't run the Haskell code and connect with the tutorial D on the same database. Again, might be because of a bug in master. I saw some things there, and I don't know. Maybe I'll send a pull request later. But for this presentation, what I'm using here is an in-process connection, right? And here I use no persistence. But I can bind, I can pass a function here as parameter, which is a notification handler, right? So one thing that is different in the Haskell context is that the notification will never be triggered by the Haskell client. And this is clearly stated on the documentation. But I'm assuming that if I can connect tutorial D terminal and the Haskell code, if I change something in the tutorial D, I will get the notification in Haskell. But here I put here just to compile and to see if the handler actually compiles and compiles just fine. Yeah, and that's it. That's what I had to show. Thank you all.
Any questions? Which you can repeat on the mic also.
Oh, yeah, yeah.
So I don't have a question, but I do have an observation. This looks a lot like the Mirage OCaml library Urban, IRMIN. They basically use Git to model of transactions. So this reminded me of that.
Nice. It's Mirage in OCaml.
Yeah, yeah. They created a database system.
Is that Mirage the standalone model kernel?
Yeah, the Unicron, right?
Or Unity?
So the project is called Urban IRMIN.
Oh, it's not Camel. Am I mistyping? OCaml has...
Yeah, no E in OCaml.
You can search for
No E.
IR.
Sorry?
No E.
No E. Oh, okay. Of course, it's ML, yeah.
And then the particular project is
IRMIN.
IR?
MIN.
Ah, there we go. Nice.
The Gallup guys are? Oh no, Gallup Haskell guys.
Mirage Lab Cambridge.
Oh, okay.
Sorry, may I mistake? Is it possible to connect this to a Postgres database and get data in?
You mean from the tutorial D? From the M36?
Yeah.
That would be a cool project. You could do a foreign data wrapper in PostgreSQL and an interface with M36. From the other side, however, you probably would have to implement some infrastructure in M36 that currently doesn't exist. But in the PostgreSQL, it should be quite straightforward, actually.
And you can do the standard sort of serialize out to Postgres.
Exactly. You could even use the WebSocket interface, and PostgreSQL has like amazing JSON support. So you basically inside your FDW, you pass JSON to a WebSocket. You would just need like a WebSocket client to compile into your foreign data wrapper. I think that's what is the piece that we would miss in the puzzle.